Hello everybody, and a very warm welcome to all our attendees and a special welcome to our OEM Bitdefender partners on today's webinar session. Great to have you all here. So we are very excited to talk to you all today over the next 35 minutes about the Internet of Things. There's a lot being talked about out there at present, but we will try summarize the Internet of Things landscape for you in terms of business potential and security risks. We will also open up a QA session at the end of the webinar, and we will encourage you to ask questions then using the chat feature on the toolbar. So let's jump right in and go straight to a great tangible example of the Internet of Things potential and risk. So ex-US Vice President Dick Cheney had a pacemaker with wireless features which enabled remote monitoring and control. A very tangible example of the possibilities of IoT, a thing, the pacemaker, that can process data and communicate. And once Mr. Cheneys' advisors became aware of the possible risks involved, they immediately disabled the wireless features. Now, the interesting thing of this story is the extreme example of potential value and risk, and also what that means depending on who the target audience is. In this case, on one end of the spectrum, you have the potential to save a life, and on the other end, you have the potential of a life being taken. Mr. Cheney, I doubt, knows anything about the risks of hacking, but his advisors saw the risk outweighed the value to be gained and disabled the functionality. Now, this is really what we'll be talking about today, the potential for value and the inherent security risks, and the importance of how that can change depending on who the target audience or customer is. The importance of understanding your audience, your public, what they need is always necessary and relevant, but even more so in the ever open, generic and muddy world that is IoT. So what about you? The question is not if you would hack Dick Cheney's pacemaker given the chance, but what is your company's IoT plan today? How much skin does your company have in the IoT game? And we're going to run a quick poll to get an idea of where your companies are at in regards to their IoT strategies and go-to-markets. And with this data, we'll be able to see if the majority is behind or ahead of the curve in regards to getting a product to market. So we can see that the results show that the majority is still looking around and not presently implementing. And that gives us a better idea of how to approach the next 30 minutes. Okay, so that's what you guys are doing in regards to products and go-to-markets. Here in this slide, we can get an idea of the mass of products that are and will be going to market shortly. And Cisco estimates that there will be over 50 billion, that's billion with a capital B, connected devices by 2020. And if we cross that with the projected population growth in the same time period, it translates to just under 6.5 devices per human being by 2020. And that's a lot of product potential. So we will have a lot of IoT things, but it is more than just about the things. As Gartner mentioned, the real challenge of IoT is less in making products smart and more in understanding the business opportunities enabled by smart products and new ecosystems. So let's have a look at some of these things. So IoT it's a broad term. It's like computing. But for the interest of this session, let's agree that it is a network of physical devices typically capable of sensing the environment and gathering and communicating that data for some type of benefit. So it's not just a piece of technology. Moreover, it is a stack of technologies where we could really look at the sensors, the physical things at the bottom, then additional layers such as communication technologies and storing and securing of data for analysis. In the context of this webinar, the level of communication and the amount of data communicated between devices is obviously of great interest. And here we have some of the most tangible examples at the bottom of the technological stack. Okay, so here we can see the light bulb, the thermostat, and the door lock, in addition to some other quirkier ones such as the fish finder for anglers. Now, these things are enabled with microprocessors and connectivity technology to transmit and receive data. Now, all of this requires software applications and operating systems to work. And as we know from previous experience, that these two are inherently vulnerable. So there's a really interesting debate going on whether the IoT is just hype, or is it just more sort of an extension of other technology waves that's already been around a long time. Either way, you should expect the Internet of Things to have a significant impact on business over the next 3 to 5 years. General Electric, in their insightful paper Industrial Internet, Pushing the Boundaries of Minds and Machines, talk about the next wave of innovation change in the history of mankind, and they talk about IoT in terms of revolutionary change, what they call the Industrial Internet Revolution, which builds on the Industrial Revolution and the Internet Revolution. They talk about it in terms of opening up new frontiers to accelerate productivity, reduce efficiency and waste, and enhance the human work experience. Another great quote came from Georgetown University Michael Nielsen when he compares IoT to plastic, and that back in the day it was almost impossible to envision that plastic would be in everything. And that could also be the case of IoT. Finally, the World Economic Forum forecasts a dramatic impact on the overall world economy. So it would be hard pushed not to go along with sentiment that this is going to be a game changer. But why now? What has everyone so excited and on the edge of their seat? Well, we seem to have reached this tipping point, as John Bullman from Intel said at his keynote at the IoT Solutions World Congress in Barcelona in September. And he said, what's so exciting is that we've gone from a promise into real developments. So basically, there is a technological environment that has created a perfect confluence of capabilities that can enable the vision. We can see that the power of computing, for example, has multiplied by 60 in the last decade. Wi-Fi, for example, in terms of connectivity, is so ubiquitous that it is either free or extremely cheap. Hardware is also getting much cheaper. Sensors costs have dropped on average 60% in the last few years, and cheaper hardware is now available to startups, and that's enabling a lot more disruption and innovation. So cheap chips are not only available to large enterprises that can leverage economies of scale, which was the case, say, a decade ago. So there are less and less obstacles to getting into the game, as it were. IP version 6 also makes the necessary room for those 50 billion devices that we talked about earlier to coexist without too much conflict. All in all, we have multiple factors that are converging and reaching a tipping point, and that is what has the market on the edge of its seat. So that is what is making the vision a reality. But what is the main business driver behind this push? And the answer is quite simply efficiencies. Having arrays of things in an environment, reporting back on that environment gives insights into what needs to be done and how it needs to be done in a more efficient way. So in this chart, we can see that the impact that would take place with just a 1% improvement in efficiencies in various industries. Now this is just 1%, and this is just focused on the US market alone. So in agriculture, just to give you an idea, there are sensors today in the ground to check for moisture, even light to regulate watering systems and guarantee optimal levels. Not just save on water, but guarantee optimal crops. Another great example is that today, approximately only 1% of data from oil rigs, generally that hold up to 30,000 sensors, is examined, and that data is generally used for anomaly detection and control, and not for optimization and prediction, which would provide the greatest value. So when we take this perspective of efficiencies, it makes sense that industry types drive more variations in attitudes to IoT than geographic region or company size. Retail, utilities, manufacturing, for example, score highest in terms of expectations that IoT would have a substantial short and long-term impact on their business. Generally, IoT will affect industries that are usually early tech adopters, such as retail. So let's have a quick look at some of these use cases, all of which will generate business opportunities moving forward. In manufacturing, we can see that IoT will be implemented to monitor and control production to increase productivity in regards to predictive maintenance, predicting breakdowns, etc. Again, efficiency here is key, ensuring higher levels of availability of manufacturing lines and increasing the quality of output. In regards to retail, there will be frictionless checkouts where you can just put your choice item into your bag and walk out without passing by the register. It will feel more like what they call stealing than shopping. So again, that focus on efficiencies. And in the case of smart cities, there are lots of great implementation success stories around the world today, where we can see in Long Beach, California, that they've implemented smart meters to enforce water restrictions. And in Barcelona, for example, and other European cities, that the street lights are set to green when an ambulance approaches. So that has a direct impact on response times and ultimately increases survival rates. Following that line of thought, in healthcare, we can see that the dramatic impact will not only be in the economies of healthcare, but also health outcomes for patients. The McKinley report, Unlocking the Potential of IoT, estimates that the value of improved health of chronic disease patients through remote monitoring could be as much as 1.1 trillion with a T per year by 2025. So all will agree that the actual and potential for value is enormous, but it also means one important thing in the context of this webinar. The attack surface is widening. So I think now will be a great time to hand over to Yunaev, who is a senior software developer at Bitdefender and one of the sharpest security minds I have had the pleasure to come across, and who also has a keen grip on IoT. George, over to you.
Thank you, Darragh, and hello everybody. So with all those business opportunities explained in such great details by Darragh in previous slides, it's obvious the increased number of vendors are trying to get into this market. But unfortunately, many of those vendors have never developed a connected device before, and they are unaware of the associated security risk. This results in the number of major compromises we have seen recently, from the remotely accessible baby monitor to the infamous Jeep hack. So why does it happen? Why, as some people say, vendors act utterly, and some people even say criminally irresponsible? And on the next slide you will see why. Vendors trying to develop a new connected device often feel they're already being too late, as their only chance to succeed in this market is to release a product as far as possible. This means that getting fast to market is a top priority for those vendors, and anything else, which includes unfortunately security, comes after that. And some vendors even make it obvious in such ways that we will either have an insecure product which everybody use and we will add security after that, or we will spend more time and end up with a secure product which nobody even knows about because we already lost the chance. This means the security for those products is an afterthought at best. Of course, most vendors don't think in such irresponsible way, but there are some other excuses you can commonly hear. A typical one would be, nobody would hack our product. We are doing internet connected mousetrap. It's not interesting at all. Nobody ever hacked those before. And then, using the same logic, nobody hacked cars before certain point. This means vendor may think, why would they hack ours? And even after it happens, after somebody actually tried to hack cars and vendor is aware that, or at least they're pressed to acknowledge that yes, car could be hacked and that they are a target for hackers. Security is typically only added on top of the existing product and not integrated into. Unfortunately, this results in a very weak security, which is much easier to disable or work around by the hackers as comparing to what if it was built into the product. And finally, some vendors, even those who want to make a secure product, simply lack necessary experience to do so. This is because developing a product exposed to internet, so-called war zone, requires different thinking than developing a product which will only be used by some trusted parties who signed NDAs and passed background checks and special trainings. So developing for internet requires different way of thinking. Basically everything, all the input must be treated as hostile, and for embedded devices every hardware input also must be treated as hostile. This includes, for example, the RF interference and power voltage. All those things have to be checked too. So if you know, for example, that your hardware sensor can only return a number from 1 to 5, and this means your code can only handle numbers from 9 to 5, and if the code receives 6, you don't know what it's gonna do. This means your device is about to be hacked as soon as somebody gets hold on that sensor. On the next slide, I will also explain why the traditional approach, such as relying on security companies like Bitdefender, doesn't work well for this environment. Here we can say to start that, well, other environments are not much secure either. Notably, many popular Windows applications such as Internet Explorer, Adobe Flash, Adobe PDF have been really insecure and had many major exploits found in them, and some still are insecure. And somehow it did not wreak the havoc similar to, for example, Jeep Fiasco. And the reason for that is that security companies, including Bitdefender, took good care of protecting your PC and did good jobs there, trying to work around and contain the security issues and limit their or expose and protect your PC from the vulnerable applications. As a result, some people ask why then Bitdefender and other security companies don't protect the same way the IoT devices, the same way they protect Windows and Mac PCs. Unfortunately, there are certain challenges here based on the following reason. First, as you see in the list on the slide, there are many hardware architectures used in the IoT devices which use different libraries, different APIs that the interface libraries communicate between other, different modes, different floating points. All those technical terms means that you have to create many different builds of the product to support all those devices with all those combinations. So if you add on top of that a large number of operating systems, for example, there could be different versions of Linux and operating system based on Linux such as Android. There could be different versions of BSD, like FreeBSD, OpenBSD, NetBSD. There could be QNX, there could be even Windows embedded. This means there is a pretty large number of the operating system and hardware configurations one would have to support. And supporting those would require some major technical effort. Second, however, and which is more important, is that typical IoT system use a computer, which is often called system on chip in this environment. But this computer has often very limited resources on those devices. Think of modern PC, which has ample resources to run an AV. There is pretty much no modern PC shipping with less than 1 GB of RAM and 64 GB hard drive. But for a typical IoT device having 124 megs of RAM and 16 megabytes, we are not talking about gigabytes, megabytes, of flash, which is disk space, would be considered very generous. The main factor playing here is cost. It's simply impossible for a $20 connected light bulb to have a 32 gigabyte flash drive on the cost factor alone. And those factors greatly limit the ability of security companies to provide a meaningful solution which would protect. Here, a short introduction how malware detection works. First, certain amount of code needs to be written to detect this malware and to analyze the traffic, the applications on the device, and together with this code some data has to be supplied to the device and stored, such as heuristic rules, signatures, and everything. So this code and data consumes some CPU and memory, and it tends to grow significantly as the complexity of malware increases. This means that the device must have a certain capability, hardware capacity to be able to run the security solution. And without that capacity, providing a meaningful security solution would be very challenging for us.
So on the next slide, we will summarize the issues that led to the recent hacks. The most obvious issue is that security is not architected in the solution, which was often based on the false assumption that nobody would even try to hack it. This leads to issues such as lack of proper update procedure, because once your solution is hacked and you need to replace the firmware to fix the hack, if you cannot do it securely, meaning there is no cryptographic verification, this means the hackers, after hacking your device, can implement a different update procedure which will reject your update, or will patch update on the fly, meaning the device will still be hacked. So there is lack of firmware self-protection, meaning the firmware does not do self-checks, does not verify its integrity, and generally is accessible to hacking. And there is no trust level separation. This was a typical question asked by many journalists during Jeep hack, was why the entertainment system in the car is even connected to brakes. It doesn't make any sense to have it connected to brakes. And the reason is there is no trust level separation. This means there is only one trust level, everything has access to everything, which makes it very easy to implement, but it also makes it very easy to hack. The second issue is sloppy, unattentive coding, which is often caused by the pressure to release the product fast. This means the routing checks are being missed, memory allocation and flash reads assumed to be always succeed, the input data is assumed to be always verifiable, and the code to recover from errors is often marked as to do and left for the late time. This leads that it's very easy to exploit any vulnerabilities in the program just by triggering an error condition, and at least by triggering that, the hacker will get a denial of service, and in the worst case it will have full control of the device. The third issue is that vulnerabilities are often hard-coded. This means, unlike the architecture vulnerability, this means the company knew that this would be problematic if somebody knew about it, but still decided to process anyway. A typical issue would be hard-coded credentials for support or remote support or administrator, which the hacker can get into device and learn, for example, the administrator passwords which are built in. It would be using unsecure communications, such as was the issue with BMW remote unlocking, which use a clear HTTP, meaning anybody can unlock that BMW, and privileged process accepting authenticated commands on open ports, as was one of the issues with Jeep hack. And the final issue is that nobody in the company even tried to hack the device. This practice, known as penetration testing, which we call pen testing, is common among security professionals. Unfortunately, many vendors joining the IoT market are either unfamiliar with this practice or natively expect their own QA department to perform it. The last one is a big mistake, because penetration testing requires not only special skills but also a very specific hacker mindset, which is rare among regular QA engineers. And lack of such testing leads to issues such as your company's product being advertised in quotes at DEF CON and, in the worst case, in national news. So, on the next slide, we will briefly discuss what could be done in this situation. Basically, when developing an IoT device, you are on your own and you are responsible for security of your device and your customers. We at Bitdefender have an article about this exact topic, which is you can see down below on that slide. But let's briefly iterate its points here. First, you must expect that the hacker will attempt to break your product. It doesn't matter if you think the product is completely uninteresting. If it's an internet connected mousetrap, even in this case, somebody will eventually try to hack it. Please keep in mind that the hackers are not doing that always for profit or for really breaking into it. Some do it for fun, some do it for self-education, some do it for having shown their hacking skills in resume, and some do it to have something to show at DEF CON. So all this it doesn't mean what kind of exposure you're hacking of your product with. This means that if your product is connected, you always have to keep in mind that when designing and developing your products. And please employ security architects and engineers to validate your assumption about everything when you do the architecture. Second, security must be built into the product. This means that your product should expect to work in the hostile environment. You should vet all the input instead of blindly trust it, and have to trigger proper reaction when the incorrect files are received. For example, if your speed sensor indicates a speed of 32,000 miles per hour, then the onboard computer should light something like speed sensor failure message and not show the speed of 32,000 miles per hour, or even worse, just crash altogether. Third, please make sure that your engineers learn and use secure recording practice. Don't push them to make it work first and handle errors later. Usually there is never time for this later, and this means the product on the market will be error prone. So if your team only developed for in-labs use before, please train them or hire extra help, because developing for internet-faced and connected world is very different from developing for in-labs, because there is much larger exposure to hackers. And of course, please test your product internally for security vulnerabilities, either by hiring or outsourcing penetration tests. Remember that the goal of this test is very different from your QA team. Saying so, that security of your device is on your own, but this doesn't mean that your customers are completely unprotected. And on the next slide, I will briefly mention some ways to protect against vulnerable devices. Note that we are talking about external solutions, not something which run on the IoT device itself. First, Bitdefender has a solution which we call Bitdefender Box, which is positioned as protector of the things. This is a home router which is plugged in between the internet connection and your home internet router, and inspects the traffic going through it. Its architecture is extendable through automatic updates, and we will be adding more and more IoT related protections such as signature exploits into it. A regular firewall would also help to protect you in-home devices from remote hacking, but with specific signatures, its protection capabilities would be rather limited. Other third-party solutions would include software such as vulnerability scanners, which would let the user scan their home for connected devices with known vulnerabilities. The problem with this solution is that it can tell you that the devices are vulnerable, but it can offer no remediation, because there is no standard interface for that, and the update procedures for some of the IoT devices are rather cumbersome. For example, to update a Wi-Fi bulb, you have to turn on and off lights several times during different time frame, which is out of scope for a simple application. So hopefully in future the IoT vendors would agree on some kind of standard common interface for security protection and for updates. So all this software would be more useful for users and easy to use and keep the devices up to date and secure. That was all from me. Off to you, Darragh. Thank you.
Excellent. Thank you, George. So there are lots of security challenges starting from the bottom up in regards to the actual mindset of companies trying to get to market first, regardless of the consequences. Also, there is a lack of security experience in these startups. Again, the focus is on the fastest route to market, not the most secure. Now, that doesn't mean there are no challenges for the security pros and vendors by any means. We are up against it also, but we are getting footholds. And in regards to Bitdefender, we are very proud to have the box, which you can find out more about on our website. But with challenges comes opportunities. So let's look at some of the good stuff that is coming down the line. In the McKinsey report, Unlocking the Potential of IoT, they estimate that the potential economic impact for IoT to be between 3.9 and 11.1 trillion with a T per year by 2025. Now, I think what is extremely interesting here is how wide that estimation actually is. 3.9 on one end of the scale to 11.1 on the other. It really just goes to show that anything could happen. Like plastic back in the 1950s, it has the potential to be everywhere. So this is the overall business opportunity pie, so to speak, and security risk will be inherent, as George mentioned earlier, in all aspects of this world going, or this market going forward. So this in turn will create additional security opportunities. Now, Market and Markets estimate the IoT security market will grow from an estimated 6.9 billion would it be in this year, 2015, to 28.9 billion in 2020. So that's a compound annual growth rate of 33%, which is indeed impressive. So even though a lot of companies today are ignoring a lot of security aspects related to IoT, the forecast is that this will change and there will be real market demand for new security products and services. Now here at Bitdefender OEM, we will help you find the fit for those opportunities. We have over 20 technologies that we license, and we are a dedicated business unit with experienced security professionals in all aspects of the business. So from business development to evaluation of our technology to the integration, and even helping you with go-to-market activities to bring your new products and services to market, through to our prized tech support to support you all the way. So please reach out to the team to see how we can help you moving forward. In summary, a dynamic industry is evolving around IoT technology. The real challenge of IoT is less in making products smart and more in understanding the business opportunities enabled by smart products and new ecosystems. In almost all settings, IoT systems will raise questions about data security and privacy. The average consumer may not be as fortunate to have advisors like Mr. Cheneys, who started off our webinar today in regards to security concerns, but security and privacy will drive a huge market for IoT security products and services moving forward. So reach out to the team to see how we can help you address your next big project or help your existing projects and products and services go to market.